Hello and welcome to another math video. This video is for the Chapter 1 and 2.1 FST test. We'll get started here with number 1. We just need to list the elements for the set. Let's see, so we write that with our set bracket, or brace. And x is a natural number less than 8. So natural numbers do not include 0, so I'm just going to go 1, 2, 3, ... less than 8, so that would go up to 7, but not include the 8. You could write them all out if you wanted to, but again, we can shorten that up a little bit. Number 2, same thing. A is an integer greater than -2. So greater than -2. So we would be looking at -1, 0, 1, and then would continue on like that. Starting with number 3, we're actually using set builder notation. So the numbers 14, 15, 16, 17. So simplest way to do that is say x such that x is an integer between, and since we're saying between, we have to say 13 and 18. And that's probably the simplest format to use for writing that in set builder notation. Number 4, similar idea, set builder notation, but notice this one is unbound, starting with -2. So that'll be a little bit different. We'll say x such that x is an integer and I'm just going to say greater than -3. Again, you could say greater than or equal to -2 if you wanted to. So there are a few variations you could use there, but this one works out pretty well. 5 and 6, we're listing the elements of the set that are of the indicated type. So we're looking at whole numbers for number 5. So 12 would work. Whole numbers do not include negatives. So -23 is out, and the square root of 7 is not a whole number. That would be irrational. 0 and 0 over 6 would both be whole numbers because they're both 0, and the square root of 16 is a whole number. Number 6, we're looking at irrational numbers. So negative square root of 16 is rational because that's -4. So is 9. Square root of 8 is irrational. Those are all rational. Pi is irrational. -3 over 0 is not a number. You cannot divide by 0. And 0.49 is rational. And so that's what we're looking at for number 6, just the square root of 8 and pi. For 7 and 8, we're looking at some absolute value expressions. So the absolute value of -18 would be 18. And then minus the absolute value of -22, which would be 22. So 18 minus 22, and that's going to turn out to be -4. Same kind of thing with number 8. Absolute value of -6 would be 6, minus the absolute value of 13, which is just 13. So 6 minus 13, and that would end up being -7. For 9, 10, and 11, we're using interval notation. Again, it looks kind of like an ordered pair, but it's not. So number 9, the values of x that are greater than 4, so we would have a parenthesis and then a 4, go up forever, so an infinity, and then another parenthesis. Number 10, the values of x that are less than or equal to -5. It can be helpful if you want to graph it, then you can see what you're dealing with. In this case, -5 there. We're looking at the values of x that are less than that, so it would go this way. That can help you see that the interval would really be -infinity to -5, Now the negative 5 also gets the bracket there because the inequality has the equal to. And then we get to number 11, which is compound inequality, or three-part inequality. Again, if you wanted to graph it, that might help you see what's going on. But really we just have a bracket, and then negative 2, and then 3 with a parenthesis showing that it's that interval from negative 2 just to less than 3. And then number 12, graphing this on a number line. Again, remember we are using parentheses and brackets rather than open and closed circles. So looking at that, all we really need to do is put a parenthesis at 4 and show that that's going to the left. We're doing the same kind of thing for 13, just graphing that. Let's see, so we have a bracket at 0, and we are going to the right because we're looking at the values that are greater than or equal to 0. And then 14 is that three-part inequality, so we have a parenthesis at negative 1. See if I can do that a little bit better. And a bracket at positive 2, and then it's the stuff in between there, so from negative 1 to positive 2. 15, there's just 5 x's there, so we just write that as x to the 5th power. 16, we do need parentheses around the 2/9, and there's 7 of those. For 17 and 18, we're just finding the square root. 576, probably one you don't know off the top of your head, but you can use a calculator there. It does turn out to just be negative 24. 18, what I would look at doing, just square root the 36, square root the 49, we get 6/7. Please use the fraction there. Number 19, we have to simplify that. Let's see, in the numerator we would add the 4 and the 4 together first. So we'd have 3 times 8, plus I can go ahead and multiply the 3 and 7 together, get 21. And then in the denominator I get 3 times 6 because I do the 7 minus 1. In the numerator I would multiply the 3 and the 8 together and get 24 plus 21. And then in the denominator 3 times 6 gives us 18. Add the 24 and 21 together in the numerator for a total of 45 over 18. And that does reduce to 5 over 2. I'm okay with the decimal 2.5 because that is exact. We follow the same kind of process for number 20. Looking at that one, we start with the, well, we can do the 5 times negative 7, get negative 35, minus the 5. I have to do the 2 cubed before I can do that multiplication, so that's 5 times 8. In the denominator, we do the square root of 121 first, and so it looks like this. Again, in the numerator, that's a 5 times 8, so we can do that first. The minus sign I'm just going to leave out there, so we get negative 35 minus 40. Now in the denominator, be careful how you handle that. You might want to think of that as adding a negative 11, but I'm going to go ahead and add the 10 and subtract the 11, or add the negative 11. I'll get negative 1 plus 10 there. So I end up with negative 75 over 9 as my answer for that one. And that does reduce down to negative 25 over 3, reduces by a factor of 3. That looks a little funny, but that is negative 25 over 3. And again, I'm not interested in the decimal there, because a repeating decimal. For problems 21 and 22, they give us values to plug in. Let's see, so we start by plugging in the value for C, so we have 8 times 7 minus 3 times B, which is 16. Let's see, we can do the 8 times 7, so we get 56. 3 times 16, we're looking at 48. So we end up with 5 times 8, which would be 40. Same sort of idea for number 22. 4 times c. C was 7 minus a squared. A was negative 5. Now again, be careful when we square that negative. That'll turn out to be positive. Whereas in the denominator, 7 times negative 5 will be negative. And then we're squaring the c as well, so squaring 7. And so doing the 4 times 7 gives me 28 minus a positive 25 over negative 35 plus 49. 28 minus 25, that's not too bad, it's just 3. And then really like a 49 minus a 35 would be 14. So 3 over 14 for that one. And then we're looking at simplifying some expressions. So we need to distribute the negative 12 into those parentheses. So we get negative 132z. I should probably try not to make my 2's and z's look so much alike there. So negative 132z. And then we get minus 96m. So negative 132z minus 96m, again making sure that we distribute that negative all the way through. Number 24, we distribute the negative 5. So we'd be looking at negative 10x. Then it would be plus 40. Again, the negatives cancel out. Minus the 4x plus the 6. We can combine the x's and get negative 14x. And then add the 40 and the 6 together, we get 46. And then we'll take a look at 25. This will be the last one for this video. Starting to get a little bit long, and so the last page will have its own video. So we start by distributing that negative 2, so we have negative 4m plus 4 plus, and then we distribute the 4, we get 12m plus 20. And we can combine m's, so we get a negative 4m plus a 12m for a total of 8m. We can combine the 4 and the 20 for a total of 24. Well, as always, thank you for watching, and hopefully you found this to be helpful. And as I mentioned a minute ago, again, we'll do a separate video for the last page of this test. Hello and welcome to another math video. This is part 2 of the FST Chapter 1 and 2.1 test. So we start with number 26, where we need to solve the equation, and before we can even really do that, we need to simplify the left-hand side of that equation. So we would distribute the 14 into those parentheses, so we get the 14 times 2c, which would give us 28c. And then the 14 times 8, which would give us 112. That's going to equal 4c minus 7. For me, I would subtract the 4c from both sides. That way the c's will be positive. And I may as well add 112 at the same time. So we end up with 24c equals 105, and so we divide both sides of the equation by 24, and we get c equals 105 over 24, which does reduce down to 35 over 8. The decimal's not too bad, it's 4.375, but still I'd prefer the reduced fraction there. For problems 27, 28, and 29, I wanted to make sure we could see the full directions. We have to decide whether it's a conditional, an identity, or a contradiction, and give the solution set. So make sure we're doing both parts. For number 27, we'd start by distributing the 5 on the right-hand side. So the left Won't do anything with that right away. Distributing the 5 gives us 25m plus 90. Let's see, this one looks like it'll be conditional because we still have some m's left after subtracting 25m from both sides. Leaves me with 10m plus 20, and that's equal to the 90. From there, we would subtract the 20 from both sides. Gives us 10m equals 70. Divide both sides by 10, and we get m equals 70 over 10, which of course reduces down to just plain old 7. So this one is conditional, so make sure that we identify that somewhere. So it's conditional, and then the solution is m equals 7. Moving on to 28, we would start by distributing the 5, which would give us 10g plus 20 minus 10g minus 100. So really all the action is over here on the left side of the equation. The 10g minus 10g would go away. 20 minus 100 would be negative 80. Since this is false, then this is a contradiction. And don't forget, then we need the solution set, which is that there would be no solution. The simplest way to do that is to just do the symbol for the empty set. Moving on to 29, we would distribute the 2. So we would keep the negative 4s plus 9 plus 4s minus 6, and that would equal 0. The 4 s's would cancel out, and 9 minus 6 would be 3. Of course, 3 does not equal 0, so this is another contradiction. And of course, again, we need to say that there is no solution, so we use the symbol for the empty set. Number 30, we just need to solve the equation. This one will be conditional. It's just a matter of dealing with those fractions. Again, what we want to do is multiply both sides of the equation by the least common denominator, which of course is the least common multiple of 3 and 5, and that would be 15. So we multiply both sides of the equation by 15. Make sure we do that to the right side as well. It's a common mistake. Now on the left side there are a number of different ways to think of this, but we do have to distribute the 15 to both the 2x over 5 and the x over 3. Probably the simplest thing to do is just think of this as a straight up multiplication. Remember that 15 has a 1 for a denominator. So 15 times 2x gives us 30, so 30x over 5 minus the 15x over 3 looks like this, and then 30 over 5 reduces to 6, and the 15 over 3 reduces to 5. So we get 6x minus 5x equals x, and then that is equal to 30. And again, we don't need to say that it's conditional. They're not asking for that on this one. So just the solution there is fine. Then we're on to the final question here, number 31. Again, this is the decimal equation. We have, let's see here, we have 2/100ths, we have 1/10, and we have 42/100ths. Now we do have a combination of hundredths and tenths, so you have to be careful with that. But because we have hundredths, we would need to multiply both sides of the equation by 100. And so on the right side we do get 42y. On the left side the 100 would distribute 100 times the 2/100ths is 2, so we get 2y plus. Now here's the tricky thing, is the 100 times the 0.1, which is really 1/10. So that's going to equal 10. And so we have 10 times the 6,000 minus y. From there we would distribute the 10. So we get 2y equals 60, not equals, 2y plus 60,000. Then I write a 2 for some reason. All right, try that again. So 60,000 minus 10y equals 42y. Combining the y's on the left would give us negative 8y. So 60,000 minus 8y equals 42y. And then from there we would add the 8y to both sides, which would give us 60,000 equals 50y. Divide by 50, and we get y equals 1,200. I haven't really mentioned it yet with these problems, but of course whenever solving equations it makes sense to go ahead and plug it back into the original. Now these decimal ones can be a bit of a pain, but that's where we can rely on the calculator a little bit to help out. But again, especially for a test question, take the extra minute to check your answer and make sure that that does work. As always, hopefully you found this helpful, and thank you for watching.